All right. Greetings, everyone. My name is Masal Gavalda, and I'm a lead in machine learning at Square. So we'll be discussing how to develop machine learning-driven customer-facing product features. But before we get into the meat of the substance of the presentation, I always like to tell you a little bit about myself, how I ended up in this area of machine learning. I grew up in Barcelona, Catalonia, Spain, speaking Catalan and Spanish, which made me very curious about languages. It's an endlessly fascinating topic, but then also computer science and math. One day my dad showed up with an HP 85, which is what got me interested in computer science. And so I ended up in this field of language technologies, which is, it's a very illustrative of how the field has changed. Here you can see a spectrogram, a representation of sound. The x-axis is time, about a second. And this is a digit in English. In fact, if someone want to guess what digit this is, you can post it in the chat. But you can in the old times, as in 50 years ago, you would write these rules that say, well, if the energy is spread out across all these frequency bands, that's kind of white noise. That's basically what's linguistics call a fricative, something like F or sh or z, one of these sounds, basically white noise, turbulence. Whereas if there's a little gap that indicates, let me see if anybody, okay, nobody is guessing. This is the word 6. That's the vowel. That's actually a gap, because before applosive, you have to close your mouth and then release the pressure. And then you see the same blob again, right? Another fricative, another S. So this is the digit 6. The reason I'm mentioning this is because instead of doing these rules, now obviously everything is data-driven. We have machine learning is really learning from the data. And so in the 90s, we would have run these through HMMs, fin Markov models. Now we would use a deep learning model to map the raw wave sound to the sequence of phonemes and the speech recognition that we will be doing. So this is just kind of a quick intro of, ML is really learning from the data. And so at Square, which was founded by Jack Dorsey about 10 years ago to solve a very specific pain point of why was it so difficult for small businesses or an artist or someone to accept credit cards. Well, this has taken off, and now we're in many places, including, if you can recognize, this is Emma Stone in her Oscar-winning performance in La La Land. I'm not sure if it was related to the fact that she was operating a Square point of sale, or whether it's a correlation versus causation. In any case, she got the Oscar. But seriously, the main thing is at Square, if you look at our progression, we start with a little white reader of accepting credit cards, but now you can basically run an entire small business on Square products and services, including team management with payroll and taxes, and catalog inventory management, etc. Which means, from kind of a data standpoint, is that this functionality that we expose, together with the growth in customers, represents this sort of a exponential explosion. Whereas, of course, we've grown as a company from a sort of headcount perspective in a more linear fashion. So this gap, by definition, has to be filled by automation mostly, but also by machine learning. The difference being automation when you know exactly what needs to happen, ML when you need to have a more nuanced or sophisticated decision. So how do we apply ML at Square? Well, the cool thing is that ML is sort of foundational to the company. We are certainly kind of a tech-first financial services company. And so you can see here at the bottom, managing risk is anytime that you deal with money, you have to keep an eye for bad actors, right? So there's this whole taxonomy of different types of risk, including things that you may not have thought of. So let me give you a quick view into this. Phishing via marketing. What do we mean by that? As there's this product called Square Marketing, where a seller can maintain a relationship with their buyers through these personalized email campaigns, and so we provide these templates and professional-looking ways of maybe suggesting your next product or a loyalty program, etc. Except that sometimes, in a few occasions, we've seen something that looks more like this example in the right, on the right, which actually is an attempt of, phishing, of getting someone's credentials through this email campaign. Obviously, this is doubly troubling for the seller, but also for Square, because we don't want to become a conduit for phishing. So machine learning to the rescue. What can we do here? What is something that sort of stands out when we look at these examples of phishing? Can we translate that into features for a machine learning model? And actually, it's a good example if you know about Andrew Ng, one of the gurus in machine learning. He has this sort of heuristic about anything that a human can do with about 1 second of cognitive effort, 1 second of thinking, we can probably automate. And this is a great example because after you've seen a couple of these phishing attempts, you realize there's something off about this. There's things like this call to action of the update account. You can check whether the URL behind the button actually matches the URL of the domain of the website, if the seller has a website. That's obviously a good, an important signal. But there's also something more sort of fundamental, which is you can look at the language being used and realize that these phishing attempts tend to use much more negative language. Problem with your account, we're sorry to inform you. Immediate response needed. And it turns out that there's this technique in natural language processing where you can turn a bunch of text into a number through sentiment analysis. And so you can compute the sentiment polarity. And this turns out to be an important signal, not by itself, but in combination with other features, we can actually become very accurate at detecting these phishing attempts. Now, when I talk about this, I always joke a little bit and say, don't tell this to the bad guys because they're going to adapt, right, and start creating marketing campaigns saying something like a wonderful opportunity to freshen up your password. It's always an ongoing battle, but if you're retrained, then you will also be able to catch these things. So this is a kind of a quick example of how the increased product surface, as we call it, is obviously great because we offer more functionality, but at the same time, you always have to be on the lookout for potential misuse of those new products and features and APIs. Now, this is managing risk. There's another layer of automating operations. And then there's a top layer of actually driving product features. And by that, I mean where the ML feature is actually visible to the seller directly, right? So let's talk a bit about that. But also mention that ML, so in this case of the phishing detector, was just this one thing. In other cases, you can actually argue that the entire sort of business unit of Square Capital, which is where we facilitate loans to our sellers, is driven by ML, right? And so ML certainly has the power of sort of driving a single feature or kind of an entire business division. Now, in Square Capital, it's quite interesting because we not only uncover this sort of opportunity within our seller base who would benefit from a Square loan, but also we're able to kind of set a range and let the seller themselves decide how much they wanna what the amount of the loan. And in fact, the average amount is just $6,000, right? Which is small compared to kind of a traditional bank. They want to go for the jumbo mortgages, but that's because traditional banks have a lot of human overhead, right? All these sort of underwriters, etc. We have a fully automated process, which means that we can be very swift at creating these offers. Now, here's a good point to talk about accuracy, because for machine learning, this is something important. Accuracy is never a single number. You always need to look at what's technically known as the confusion matrix, which is, let's look at all the possible cases of the actual, what is in reality versus what the model predicted. And there's, obviously in this case of whether a seller is creditworthy, there's sort of the happy path of everybody. So the model says yes, and actually is yes. So happy seller, we got the loan, we also got it back. Everybody is happy. There's also a true negative, like maybe a seller is just very recent to the platform. We don't have enough information, so it's not a good candidate at this point. But then you also need to look at basically the two types of mistakes, right? Let's look at a false positive where we issued a loan, but actually we're not getting paid back. So the kind of delinquent state. And then we have to be careful because then we're not just missing out on the interest, but obviously we're also responsible for the principal. But then there's also the counter, which is a false negative, which means we didn't issue a loan, but we should have, because, and of course, this is, just by listening to my more sort of hypothetical language, tells us that it's harder to know because, well, we didn't issue the loans. How do you know? Well, you don't know now, but you can look at, in 3 months from now, or you can look back and see what did the model do 3 months ago, 6 months ago. And if it turns out that this seller just opened another location or their GPD is growing very quickly, then it does feel like a miss, right? It feels like the model should have selected that seller as well. So the main point, though, is that it's a balancing act, right? So there's these technical metrics of precision and recall, which basically measure of the sellers that you select, how many are good, but also takes into account the ones that you forgot about, right? So the like the false negatives, the good sellers that you didn't pick. And so you can play with this. You can imagine that a model sort of is either more strict or more relaxed. And if you're worried about you want to have higher precision, you make kind of the circle smaller, equivalent to having a higher threshold for confidence. The point is that it's a real trade-off. And so when you think about which model is best, well, actually, it has to be, it's ultimately a business decision, but the good news is that it's informed by the data. And also, in this case of offering loans, we have to, it's a highly regulated area, so we also need to prove that there's no demographic bias, meaning that there is no so-called, there's these protected classes, and so we need to show that there is no so-called disparate impact on protected classes. And also, it's good to be able to interpret why a decision was made. And so in certain cases, we might prefer a simpler model like a decision tree that naturally sort of partitions the decision space in these more like rectangular shapes because it's all a bunch of questions. And so rather than a more complex a model that will be maybe harder to explain why a particular decision was made. So what about a feature that is visible? Well, these are sort of the 4 key areas that we want to take care of. One is the design. Will users care? Is this going to be something that users will appreciate? So there's functionality, aesthetics, and all like UI, UX. But also, this is a crucial point, how is the feature going to behave when the model makes a mistake? Because it's not a question of sort of if, it's a question of when, otherwise it would be automation. Right? Which leads us to the next part. Automation obviously is about the accuracy of the model, what features, like the example of the phishing, the sentiment analysis, what else, what other data sources we have access to. And then there's the engineering, because maybe a data scientist came up with a very sophisticated and accurate model, but it's not practical to run it for millions of users. So robustness, latency, throughput, scalability is sort of the domain of this third aspect. And then finally, analytics. Is it successful? When we deploy it, we have the right instrumentation to capture usage and adoption. And also because we're talking about ML, we want to capture that usage in a way that allows us for this sort of a virtuous cycle of capturing the results and then feeding it back to the model so that it sort of delivers on the promise of improving over time. A quick example is item suggestions, where we know you're a bakery, and so we suggest that you have cookies, and then if you create an item called cookies, we'll automatically suggest the most likely variations, as we call them. For example, or a croissant. For a croissant, we're going to say chocolate, almond, butter, as opposed to small and large. That would be for coffee, right? And the cool thing is that we've learned these directly from the data. In fact, we create this, we train these embeddings using word2vec and other NLP techniques, where we learn, for example, that whereas small and large are opposites of each other in sort of normal English, within the context of item catalogs, small and large are actually semantically very close because they're all being used to model the attribute size. And so we put all these together using sort of Python and Java. And then when we launch it, we want to have this, we mentioned this feedback loop where we capture the feedback so that we can get the model to improve over time. So if we do all of that, then we can arrive at a successful ML-driven feature. And I'm almost out of time, so I think I'd rather stop here and take a couple of questions. Otherwise, let me just finish up with how does this, so this is about a feature. What about this larger theme of adopting a mindset? Well, so the main thing is being able to make sure that people understand kind of what's possible with ML. And so a little bit of training, some of these concepts about data and features and accuracy, which then allows them to brainstorm about, what could ML do for my team or my customers, which typically leads to the realization that you have to treat data as a first-class citizen, meaning put the same care in the function that you put in the functionality of a feature or an API. Use that also for the data that a service consumes, but even more important, the data that a service generates. Sort of publish that in a way that makes it easier for other teams and services to understand and consume it, which then leads to this fourth point, which is sort of the ultimate situation where you're actually weaving ML into your products and processes. It's not just analytics that is sort of bolted to like on the side with a supervisory role kind of watching over some log files. No, ML is sort of inherent into how a product behaves. And of course, all of these following ethical principles and practices, because we do need to be cognizant of the power that ML has in society. And this is a complex topic, but in general, we want these models to be fair, to be accountable, to understand why decisions were made, and also to be evolving, to make sure that we create a society that we would all want to be part of. Cool. And I see there's a couple of quick questions. Biggest challenge. Actually, the biggest challenge is among all the when we do these brainstorm sessions, there's like literally hundreds of ideas that show up. Sort of prioritizing and understanding a bit of a trade-off between the difficulty of the model versus the expected benefit. So basically, prioritization of ML models is kind of a challenge, but obviously a good one to have. And then compliance regulatory requirements. Certainly, we are abreast and following GDPR in the European Union, CCPA in California. We're very aware of the different sort of data privacy policies, right to be forgotten, etc. So it's just a matter of when you build this feature, also have the kind of the mechanism to be able to respond to any of these requests. And with that, I think my time is up. So I appreciate your attendance, and I'll stay around later for another roundtable. And I can always reach me out at Masal@squareup.com. Thank you so much.